The United States Navy operates the most advanced mine countermeasures force ever assembled. 11 Avenger-class warships specifically designed to find, classify, and destroy naval mines. AN/A QS-20 sonar systems capable of mapping the seabed at operational depth. MH-53 Sea Dragon helicopters that can sweep an influence minefield from the air without putting a hull in the water. Remote-operated underwater vehicles that neutralize contact mines at 200 feet below the surface without a single diver in range. When Iran began deploying naval mines across the Strait of Hormuz, the Navy left most of that force in Bahrain Harbor. Not because it couldn't clear the mines, because clearing them was the wrong answer to the right question. That distinction is what this video is about. The Strait of Hormuz is 21 nautical miles wide at its narrowest point, the distance between the Iranian coastline at Bandar Abbas and the Omani Musandam Peninsula. Inside that geometry, the navigable shipping lane, the water deep enough and wide enough for a laden supertanker, is approximately 4 miles across. 2 miles in each direction, separated by a traffic separation zone. The International Maritime Organization formalized in 1995. 4 miles of water. That is all that stands between 21% of the world's daily oil supply and the economic disruption that follows its interruption. Iran has been studying those 4 miles since 1984. The IRGC Navy's mine warfare doctrine is not improvised. It draws on Soviet-era designs, North Korean transfer technology, and 4 decades of domestic development at facilities near Bandar Abbas and on Qeshm Island. Iran's operational mine inventory includes 3 weapons that matter for this analysis. The INMU, a moored contact mine modeled on Soviet Cold War designs. It floats at set depth on a mooring cable, detonates on hull contact, detectable by standard sonar. Also the weapon Iran used most successfully during the tanker war of the 1980s, the M08, a moored influence mine. It responds not to contact, but to the magnetic and acoustic signature of a passing vessel. No physical touch required. A tanker transiting 30 meters above it can trigger detonation. Detection is harder, but achievable with the correct sweep configuration. And the EM52, the mine that breaks the conventional clearing equation entirely. The EM52 is a rocket-propelled rising mine. It does not float. It does not drift. It settles on the seabed in water up to 100 meters deep and waits there, passive, inert, invisible to the casual sonar pass, with a sensor suite monitoring the acoustic, magnetic, and pressure signatures of everything moving overhead. When a vessel matching its program target profile crosses its detection threshold, the EM52 fires a rocket motor that propels its warhead upward through the water column at velocity. The corridor you swept at noon can kill a ship at midnight. Conservative estimates from the Center for Strategic and International Studies place Iran's deployable mine inventory. Weapons that could reach the water within 72 hours of an execute order, at over 1,000 units. That figure does not include secondary stockpiles at the Jask Naval Base, a facility specifically positioned on the Gulf of Oman coast to give IRGC mine layers access to the approaches of Hormuz from outside the strait itself, bypassing whatever cordon the Navy establishes inside the choke point. 1,000 mines, 4 miles of navigable water, a deployment platform that operates beyond the range of the Navy's forward cordon. Here's the MCM equation. An Avenger-class mine countermeasures vessel operating under optimal conditions. Calm seas, clear water, cooperative acoustic environment, sweeps approximately 0.5 square nautical miles of water per operational day. The navigable area of the strait's shipping lane runs to 84 square nautical miles. Maximum effort. Every available Avenger committed. Ideal conditions throughout. 168 days to clear the strait from end to end. Iran's mine-laying capacity, operating from fast patrol vessels, modified commercial Dhows, and IRGC submarines running out of Bandar Abbas, can reseed a cleared corridor in 48 hours. This equation was not new. The Navy ran it after the USS Samuel B. Roberts struck an Iranian M08 mine on April 14, 1988. The Roberts was a guided missile frigate transiting a corridor that had been assessed as swept. 10 sailors were wounded. The keel was fractured. Repairs cost $96 million and took 5 months. The mine that hit the Roberts was laid after the corridor was cleared. Iran studied the Roberts incident. They commissioned their own after-action analysis. The lesson they extracted was precise. A mine-sweeping force clears the past. Iran lays mines in the future. The mine-laying cycle time is shorter than the clearing cycle time. The sweeper can never win that race. Now let us run the cost asymmetry. An Iranian M08 contact mine costs approximately $15,000 to manufacture and deploy. Neutralizing it, the full MCM sequence of sonar classification, Mark 18, Mod 2 underwater vehicle dispatch, demolition charge placement, controlled detonation, and post-clearance verification costs the United States between $50,000 and $200,000 per mine, depending on depth, water conditions, and mine type. A 10-to-1 cost ratio in Iran's favor at the conservative end of the range. The EM-52 makes it worse. Its seabed position creates a detection geometry that standard influence sweep systems are not optimized to address. The AN/AQS-20A sonar can locate it, but not reliably at operational sweep speeds. Reducing sweep speed to improve detection accuracy further reduces the clearance throughput the Navy needs to maintain an open corridor. Every mine that Iran deploys is not designed to sink a ship. It is designed to do something more economically damaging. Force the minesweeper to treat every square meter of water as suspect. Compress the navigable lane. Make every tanker captain in the world price the uncertainty into a decision about whether this transit is worth the insurance premium. The London market moved within 72 hours of the first mine report. War risk premiums for Hormuz transits increased by a factor of 8. At that point, the mines had not hit anything. The economic damage was running without a single detonation. That is not improvisation. That is engineering. Type equation in the comments if the math just changed how you see Iran's mine strategy. Subscribe to Navy Response, because what we just showed you is the doctrine Iran published. And what we are about to show you is how the US Navy answered it without touching a single mine. The correct answer to a minefield is not a minesweeper. The correct answer is to destroy the mine before it reaches the water. The logic runs like this. A mine sitting on the seabed of the Strait of Hormuz is the final link in a logistics chain. Someone manufactured it. Someone stored it. Someone transported it to a deployment vessel. That vessel moved it to position. Every step in that chain is a target. And eliminating the chain is faster, cheaper, and more durable than neutralizing the payload at the end of it. Iran's mine-laying operation runs on 3 platform types: IRGC fast patrol vessels with mine rails installed along the stern, Fateh-class coastal submarines operating out of Bandar Abbas with mine-laying capacity through their torpedo tubes, and the Dhow network, the most complex targeting problem in the theater. The fast patrol vessel problem is solvable from the air. The MH-60R Seahawk, operating from Arleigh-Burke-class destroyers in the Carrier Strike Group, carries the AGM-114 Hellfire, a 49-kilogram semi-active laser-guided weapon with a shaped charge warhead. An IRGC mine layer carrying 20 M08 mines represents $300,000 worth of ordnance aboard a vessel whose armor is its fiberglass hull. A single Hellfire engagement costs $70,000. The ratio inverts. The cost asymmetry that ran 10-to-1 in Iran's favor in the mine-by-mine clearing equation now runs 4-to-1 in America's favor in the platform targeting equation. The submarine problem is different. We covered the P-8, Poseidon's anti-submarine geometry, in the earlier video on IRGC underwater operations. The sonobuoy fields. The magnetic anomaly detection pass. The geometry of prosecuting contacts in water averaging 90 meters deep. The short version: the Persian Gulf is not the submarine's natural environment. The acoustic conditions that make submarines survivable in deep water, thermoclines, density gradients, the ambient noise that masks propulsion, are degraded or absent in shallow tropical water. The Fateh class is detectable. Prosecuting it continuously is the challenge. The Dhow network is the hardest targeting problem of the three. Iran operates approximately 2,000 registered commercial Dhows in the Persian Gulf. The IRGC uses a portion of these. Estimates range between 40 and 100 vessels on any given day, as cover for mine laying and surveillance operations. A Dhow carrying 6 M08 mines is visually indistinguishable from a Dhow carrying fish. Acoustically indistinguishable. On radar, identical. The answer is not visual, it is behavioral. The MQ-9B Sea Guardian, the maritime patrol variant of the Reaper drone, operating from Al Dhafra Air Base in the UAE, can maintain persistent ISR over a fixed geographic area for 27 hours without refueling. It carries electro-optical and infrared cameras, a maritime surface search radar, and an inverse synthetic aperture radar system that classifies surface contacts by hull profile and motion pattern. The Sea Guardian does not identify a mine layer by what it carries. It identifies one by what it does. A vessel conducting mine-laying operations moves differently than a vessel conducting commerce. It reduces speed to minimum steerage. It stops in water 30 meters deep or greater, the minimum deployment depth for most Iranian mine systems. It follows a repetitive course with no commercial destination logic. It lingers. That behavioral pattern, tracked across thousands of contacts over hours of persistent observation, produces actionable intelligence without requiring anyone to see what is on the deck of the Dhow. Pattern recognition at scale is what the MQ-9B's sensor suite, feeding data to the E-2D Advanced Hawkeye's tactical picture, enables in real time. In the video on USS Tripoli's deployment to Hormuz, we showed you the LCAC, the Landing Craft Air Cushion. Let us go deeper into what that vehicle does to Iran's mine threat geometry. The LCAC rides on a pressurized air cushion that keeps its hull out of contact with the water surface. 60 tons of payload capacity. The air cushion distributes that weight across a footprint of approximately 1,700 square feet. The resulting point pressure is roughly 70 pounds per square foot. The EM-52's pressure sensor is calibrated for vessels generating 200 pounds per square foot or greater. The load signature of a laden supertanker. A naval vessel displacing thousands of tons. The acoustic and pressure signature of real maritime traffic. The LCAC generates 70 pounds per square foot. The EM-52 does not register it as a valid target. The mine does not fire. The LCAC passes through a seeded minefield. It does not sweep it. It does not clear it. It simply does not exist within the mine's targeting physics. That is not an accident of design. The LCAC was selected for exactly this operational characteristic, and Iran had not included it in the mine threat modeling it published. Let us put the full equation together. Iran's mine strategy rested on 5 assumptions. The United States had quietly answered each one before the first mine entered the water. Assumption 1. The Navy would respond defensively, committing MCM assets to clearing operations, validating Iran's strategic logic, and absorbing operational tempo into a sweeping cycle Iran could always outpace. The answer: withhold the Avengers. Keep them in Bahrain. Refuse the defensive posture entirely. Every Avenger held in port is an Avenger not consumed by a mine-laying race it cannot win. Assumption 2. Mine-induced economic pressure, the insurance spike, the rerouting of commercial traffic to the Cape of Good Hope, the disruption of LNG contracts, would fracture the international coalition faster than American deterrence could hold it. The answer: carrier presence as economic signal. The announcement of USS Abraham Lincoln's operating position within 200 nautical miles of the strait, before a single coordinated engagement, collapsed the initial premium spike by 40% within 96 hours. Not because the mines were gone, because the signal said the corridor remained under American air umbrella. The premium responds to certainty, not to cleared water. Assumption 3. Cost asymmetry favored Iran in every mine-related engagement, and would do so indefinitely. The answer: shift the targeting from the payload to the platform. The hellfire against mine layer equation inverts the ratio from 10 to 1 against to 4 to 1 in favor. Platform targeting is faster, cheaper, and more strategically durable than mine-by-mine neutralization. Assumption 4. The Dhow network was below the threshold of actionable intelligence and would remain a persistent, untargetable mine delivery capability. The answer: MQ-9, B persistent, ISR, plus regional partner integration. Bahrain's Royal Naval Force maintains its own monitoring network covering the southern Gulf approaches. Combined with American ISR, the behavioral classification picture reaches a density that makes the Dhow network visible, not individually, but as a pattern. Assumption 5. The EM-52 and the broader seabed mine inventory would remain an enduring threat to any naval movement through the strait, regardless of how many surface mine layers were suppressed. The answer: the LCAC, which the mine cannot see. Iran had wargamed a version of this conflict, based on IRGC published doctrine and exercise patterns observable to American intelligence. Iranian planners had modeled a US response that looked like Operation Earnest Will, the 1987 to 1988 tanker escort mission, where the Navy committed to defensive corridor operations and MCM sweeping, while Iran continued to mine faster than the sweepers could clear. That model was accurate for 1987. The Navy had not advertised that it updated the equation. Here's what the math does not close. The Jask Naval Base, Iran's facility on the Gulf of Oman coast, specifically commissioned to give IRGC mine layers access to Hormuz approaches from outside the strait, was not fully neutralized in the initial targeting package. Its inventory status is not publicly confirmed. Striking a facility 200 nautical miles from the strait, on the open ocean coast of Iran, requires a different strike authorization than targeting an IRGC fastboat inside the Gulf. That authorization has its own timeline. The Fateh-class submarine, after the first week of operations, shifted to reduced emission night transits and sporadic communication patterns that degraded the P-8's ability to maintain continuous prosecutable tracks. Tracking a contact and interdicting it are not the same equation. The ASW picture in the Persian Gulf in a contested environment is managed, not solved. And the London insurance market does not reset to pre-crisis rates when mine-laying platforms are suppressed. It resets when the market believes the threat is structurally over, not operationally reduced, but categorically resolved. That is a political outcome, not a military one. The carrier strike group can suppress the mine-laying rate. It cannot sign the diplomatic instrument that tells the actuaries the threat is gone. The strait carries 21% of global oil supply. Every day the premium stays elevated. Every day tanker operators choose the Cape of Good Hope. 15 additional transit days, approximately $1.2 million in added operating cost per voyage. The economic damage accumulates without a single additional mine being deployed. Iran understood this from the start. The mine strategy was never designed to close the strait. It was designed to make the strait expensive. And expensive does not require success. It only requires uncertainty. The Navy broke the operational equation. The economic equation is still running. Subscribe to Navy Response. Because in the next video, we are going to show you the asset the Navy deployed specifically to collapse that economic uncertainty at its root, and why that deployment revealed a capability the IRGC had assumed Washington no longer prioritized. We don't celebrate weapons. We calculate whether they work. I'm your host at Navy Response.